Hello, this is Ms. Kovacs. Today we're going to be going over some more properties about logs. So this is similar to 622 in your textbook, but instead of doing those problems, we're going to learn the same stuff in a different way. So to start things off, I'd like us to recall this property that we learned last week, and that was called the power rule. Be sure to be following along. You're going to be writing this stuff down in your notebook or wherever you record your classwork. You'll be turning it in to get attendance for our asynchronous day. So the power rule told us that if we have the log base b of a to the x, we can rewrite that as what? We're going to rewrite that as x times the log base b of a. And that allowed us to solve things. It allowed us to solve equations like if I have 2 to the x is equal to 5, it let me figure out how to do that. So if I were to solve this, the first step would be what? That's right, we're going to take the log of both sides. Just another operation, right? We're going to use our power rule, x times log of 2. And then we're going to be able to isolate x by dividing by the log of 2. So we get x is equal to log 5 divided by log 2. We can approximate that on a calculator, but I'm just going to leave it there for now. All right, so one cool property that we are going to be learning about as far as logs is being able to calculate a log using our calculator, which only operates in base 10. But we're going to be able to do that for any base. And so to do that, let's look at an example. So if I have log base 2 of 30. First of all, just using some intuition, what is the value going to be approximately of the log base 2 of 30? Well, we know that the log base 2 of 16 equals 4, because 2 to the 4th is 16. We know that the log base 2 of 5 is, of 32 equals 5, because 2 to the 5th is 32. So we know that this number is going to be somewhere between 4 and 5, probably pretty close to 5, like 4.8 or 4.9. But how can we be sure? Like, how could we actually calculate that exact value? So to do that, let's take a look at kind of playing around with it a little bit. So if I have the log base 2 of 30, let's set that equal to y so we can play around with it a little bit. What's another way that I can write this equation? Let's write it in its exponential form, see where that gets us. So if I write it in my exponential form, we get 2 to the y equals 30. And now this looks like something that we just talked about how to solve. What are we going to do to both sides? We're going to take the log of both sides and use that sneaky little power rule to get that y down in front. So we'll get y times the log of 2 equals the log of 30. Now we just got to get y by itself. And voila, we are going to get y equals log 30 divided by log 2. And we can calculate that. We can approximate it on a calculator. And so that's pretty sneaky, right? I want you guys to try. So that was your example. I want you to try one on your own. I'm going to have you guys try 2 problems here. Let's start with A. So I'm going to have you calculate the log base 5 of 100. And I want you to do that using the process we just did. So when you're calculating it, you should start by saying, okay, let's set this guy equal to y. We can do that. We can say, hey, it's equal to a number. And then we can rewrite it in exponential form. And then we can take the log of both sides. We can bring down that y using our power rule. And we can divide it out to get what y equals. So y is going to be the log of 100 divided by the log of 5. All right, here's a second one for you to try. We're going to try the log base 7 of 3. So try it for yourself. What do you get? Remember the first step, I'm going to show you how to do it now. The first step is say, okay, look, I know that this is equal to a number. Not sure what to do with that. Let's write it in its exponential form. This is starting to look kind of sort of familiar. Let's take the log of both sides. Log of 7 to the y, log of 3. We're going to use that power rule. Let me just get this out of the way here. We'll get y times the log of 7 equals the log of 3. So y must be equal to the log of 3 divided by the log of 7. All right, so moving right along here. We've just uncovered what we call the change of base formula. And this is going to allow us to finally be able to use that calculator to calculate a log no matter what base we're in. So if I have the log base b of a, we just learned that that's going to be the same as the log base, whatever we want, let's call it x, of a divided by the log, same base, of b. So the log of a goes in our numerator. The log of b goes in our denominator. All right, let's try it out. So just straight up calculating, what are we going to get if we try to calculate the log base 3 of 59? What is that equivalent to according to our formula? We're going to take the log of 59. We're going to take the log of 3. And that's going to get us our approximate decimal answer of 3.712. All right, so we've got our power rule, we've got our change of base formula. Let's talk about some other cool properties. The first one of these is called the product rule. So you guys might remember from exponents, if I have b to the power of x times b to the power of y, what do I get as my result? Well, we're multiplying bx times plus another y times. So our exponent becomes x plus y. Today, we're going to talk about the product rule for logs, which, as you might expect, is like the one for exponents, except inverse. So for logs, if I have the log base b of x plus the log base b of y. That's the same as the log base b of x times y. So when we're thinking about exponents, it's almost like the multiplication becomes addition. When we're thinking about logs, if I'm adding together two logs with the same base, we can think about that as the log of the product, x times y. So let's see if we can apply that. I'm going to ask you all, if I wanted to calculate the log base b of 3 plus the log base b of 5, what is that equivalent to? We get the log base b of 3 times 5, otherwise known as 15. Awesome. So some of you are probably like, what the heck? Like, why does that work? And if you stick around, I'm going to have a bit at the end explaining why these rules work. But for now, we don't have a lot of time, so let's get right to it. So that was our product rule. Let's take a look at our quotient rule. So again, first I'm going to relate it back to the exponents. You all might remember if I have b to the x divided by b to the y, that's going to be equal to b to the power of what? Hopefully you said x minus y, right? All of the numbers in the bottom become giant ones with any of the same values in the top. So essentially we're taking away all of the y b numbers that are in the bottom. So similarly, if I'm dealing with logs, we think about the inverse. If I have the log base b of x minus the log base b of y, that's going to be the log base b of x divided by y. So let's check it out. Apply this rule a little bit. You tell me, if I have the log base b of 20 minus the log base b of 4, what is that equivalent to? Well, we're going to take the log base b of 20 divided by 4, otherwise known as the log of 5. Pretty crazy, huh? All right, we're just going to have 3 quick practice questions to make sure everything has sunk in nicely. And then you'll have more of a chance to practice this on your log properties worksheet, which is assigned on Canvas from your teacher. So, but before you go, let's practice. The first thing I'd like you to do is change the base. So calculate the log base 3 of 85. We're going to use the tools that we just learned. How can we plug that in a calculator? The second thing that we're going to do and I want you to convert to base 10 to do that one so you can plug it in your calculator. The second question I'd like you to look at is if I have the log base b of 15 minus the log base b of 30. I can rewrite that as the log base b of what? And lastly, if I have the log base a of 6 plus the log base b of 10, how can I rewrite that as a single log expression? All right, let us know what you think. Again, this is all practice, so if you get stuff wrong, that is okay. That means that you're learning. And you can check out the next video if you're interested in learning why this all works.